I heard another day that it's probably the worst thing to be between a Hungarian guy and his lunch. Probably it's the same for beer. So I will try to finish sharp. So my name is Csaba Fitzl, and I will talk about how to convince a malware to avoid us here today. So I'm a blue teamer, so for the past 5 years I'm working in an incident response team to fight malware, to find viruses in the organization, analyzing malware, network traffic, and so on. I'm a security researcher. I have a blog, although that's not so active for the past couple of years, since I have a son. I also have a wife, and I like to do hiking in my free time, besides doing security research. And actually this picture was made in the Alps 2 years ago, I think, or a year ago. So what's this talk about, really? Basically this sign. So in the real world, if we want to keep people away from a certain place, we will either show them that it's unhealthy for them, so they might fall down a cliff, or there is some biohazard or nuclear radiation, and as people don't like to die, they will avoid that place. And the other way is that prevent people getting somewhere is to say, okay, if you come here, you will get a fine or something, punishment, whatever. So we place signs to keep people away. And the question is, can we do this also with malware to keep them away? And the answer will be yes. And the agenda is divided to 3 parts. The first one is I will go through high level what malware authors or what malware is afraid of, what they want to avoid. Then I will go through some real world samples to show that actually they do this, or they try to avoid or detect some stuff. And in the last part, I will show some proof of concept tools which can help in this field. What malware authors are afraid of? Basically, security researchers or malware analysts, because security researchers can basically reverse engineer the entire code, the entire malware, discover how it works, their operation, find C2 servers, basically uncover the entire software. In most cases, it can be hard, but essentially it can be done. So, and malware authors doesn't like being analyzed, or they don't want their infrastructure to be uncovered or their malware to be analyzed. Because if it's done, they might get caught, or AV companies can write nice signatures, or they can detect the behavior of the malware and so on. So it's not nice for malware authors, so they will try to keep away themselves from security researchers. They will try to avoid sandboxes as well. Why? Because sandbox, essentially, it's an automated malware analyst. To put it simple, it will analyze the behavior of the malware and so on. So they will try to avoid sandboxes. They will try to avoid virtual machines, because that's usually the platform where malware analysis is being done, because no one likes to do it on a computer because it's hard to reload, whatever. It's easier to do it on virtual machines. Some cases it will try to avoid some hardened machines. Maybe if a specific antivirus is running, or antivirus is running at all on the machine, they will try to avoid it. Or maybe some certain targets. Maybe if the target is having like a Russian keyboard, they will, okay, I will not infect Russians, just, I don't know, US people, or vice versa, whatever. Put in your favorite country. So really these are the stuff that malware sometimes will try to check and go away if it finds something. Now, how do they detect it? This topic actually, this will be a very short overview. I think just talking about this topic could take like weeks. It's huge on itself. So probably the first most classic one is debuggers. Malware doesn't like being debugged because it means that someone watching him, what it's doing, and no one likes the big brother. So the most classic way to do it is simply call the isDebugger_present Windows API call, and if it's being debugged, it will tell yes, you are being debugged. Now it's easy to take the result of it, so maybe they will go directly and check the isDebugged flags on the PEB, the process environment block table for being debugged. Now actually isDebugger_present is checking the same flags. So they can do it directly as well. They can check other flags which are different in case being debugged. Another nice method is the output debug string. Basically, if you call this function and there is no debugger attached, it will produce an error because it cannot send an output to the debugger. And if it succeeds, then it means that there is a debugger attached. So a malware author can call this function, and if it succeeds, it means that there is a debugger attached. It can do some timing-based checks. RTDTSC is an SMD instruction. It's read time step counters. It's basically checking some time counters in the CPU, and if long time passed, then it will know that it's being debugged. Because if the application is running natively, it will take like a couple of milliseconds between two checks, but if it's running in a debugger, it can take seconds, or if the analyst is going step by step through the instruction, it will take minutes, maybe hours between two checks. It can try to self-debug itself, like it can try to attach a debugger to itself, and if there is already a debugger attached, then this will fail. It can search for int3 instruction in the memory. Int3 instruction is placed by the debuggers for breakpoints, and if the malware will find this instruction in the memory, it knows that someone is debugging it. Or just check Windows names like olidebug or windebug or whatever. And these are just a few methods. There are plenty of others. How it can check for virtual machines? It can look for registry, file system artifacts, processes running, MAC address. So let's say you install VMware tools. It will place entries in the registry, it will have file system entries, and it will have a process running. If you have like either a VirtualBox or any VM, it will have very specific MAC address if you don't change it by default, which is tied to either VMware, VirtualBox, or whatever sandbox you use. It can call some low-level instruction. VMware has a famous I/O port that can be checked. Or there is a red pill instruction, which is basically a low-level instruction to check for global descriptor tables, and that will return differently in case it's a VM or a physical machine. And you can see that these are common stuff. So like Cuckoo has already built-in signatures for detecting these items if malware is checking for this stuff. And this is because it's so frequent. Sandboxes, that's another great topic. I would recommend to check out Zoltán Balázs talk from 2 years ago, I think. Sandbox detection for the masses is basically he enumerated sandboxes, how they look like internally. And you can actually detect sandboxes by screen resolution. Like many of them will have 800 times 600 pixel resolution. Now, these days, who on earth has this resolution? I mean, if he has them, probably it's a so old computer that you can just leave it in place. Or the number of installed software on a computer. Now, Sandbox will have maybe, like, who set up a Cuckoo in your life? So what you typically put in is Office, Adobe, maybe Flash, and that's it. You leave it alone, and run it. But in real world, you will have like games, probably more than one, other application. So I myself have like 50 on these machines, which is much more realistic than like 3. Or just check the number of cores. People don't like assign multiple cores to a Cuckoo VM or any VM because it takes up resources. But in fact, you cannot buy a computer for the past 10 years without 2 cores at least. Also memory, the same reason. You don't assign too much memory to a VM. Like many sandboxes run with half gig memory, but for the past few years, you will at least have 4 gig, I think. That's a really realistic expectation. And the desktop. So if you ever set up a Cuckoo with XP, probably this is how your desktop looked like. At least this was true for me. But in fact, this is how a real desktop looks like from a real person. So he will have like multiple icons on the taskbar, applications running, browser with at least 10 tabs or more, and like it will be used. And there are many other stuff that you can check for. You can check for antivirus, again, registry, file system, or just if any product is registered. So the same story with this. So let's see some real-world samples. Do you remember WannaCry from May and the story behind it? So what happened there, the malware author said, okay, we will just try to look up a random domain, and if it gets resolved, then we can detect that it's a sandbox, because sandboxes typically resolve every domain. So they try to look up an unregistered domain, which was hard-coded, and a British guy, Malware Tech, actually he spotted this domain and he said, okay, I will just register it, who knows, and he served those pages, and effectively this killed the malware for a while, because the malware shut it down itself if he could resolve the domain and load at least a web page from there. So this is one thing that I'm trying to get in there. That there are some things that can help you to stop a malware from operation. This is taken from a word dropper. That's the hash up there. So you can write it down or take a photo, and actually you can download it from malware.com or VirusTotal, or I think it's up there somewhere, or multiple places. It has a macro, obfuscated, but there was one line which really stands out, this call, and it checked the recent files count. So typically in a sandbox, you set it up and leave it there. So you don't really have any recent files open, like maybe 1. But in a typical computer, it will be like 20, or you will hit the max of the actual OS you are using. But in a sandbox, no. So it actually checked for the recent files count, and if it was below 3, it haven't done anything. So there is a function called to, so if this is true, then it takes an error. Another one, this is a Trojan. I don't really know which one. Unfortunately, the screen is not seen very well, but essentially it will check for plenty of stuff. So like Wireshark, Sandboxy, Windows Sniffer, pop-up cleaner, whatever it is, and so on. And it will also check for an AV called Super Anti-Spyware. Don't ask why for that one, and if it found any of them, then it simply quit, which is nice. So if you would have any of these running, you are fine. So you get rid of the malware just by having the tool. This is Tesla Crypt. It went on and tried to detect an AV, like ESET in this case. So nice job, ESET. Just your existence protects against Tesla Crypt or at least against this variant. What it did, if it found this in the registry, then it gave up and quit. And actually, I can show this. I have quite a few demos, so all of them are recorded. So I will have this Tesla script running, and as you can see, ESET is not in the registry. So I will just start the malware running. So the malware is right there, it's running, and I will fast forward a little bit. So actually it cloned itself to another process, and it's running. And we can see that in process monitor that there are like 4,200 events, and it checked for ESET, and it didn't find it. So it went on and operated. Again, about 4,000 events in Prosmon. Now, if I run the same malware, but placing ESET in the HKey local machine subentry and start the malware, so right now it has about 500 events. It will take some time for it to actually move on. So now it's at about 600 events. And as you can see, the malware is not there in the Process Explorer. So it's already gone. And if we check in Prosmon, it tried to find ESET, and it was success. So it did found the entry in registry, and it quit after like 600 events. So just this registry entry basically saved the computer from getting infected by Tesla crypt. So you might get the idea where I'm getting with this. So what's the problem with today's research? So what's in the focus? So it's a known thing that malware is looking for VM artifacts and all this stuff. But what's in the focus is that malware researchers are trying to do their job, and they are developing tools, or every people is developing tools to actually hide that this is a VM, or hide that there is a debugger running, or hide that there is any analysis tool at all, or hide that there is a sandbox. So they are trying to hide all of this so the malware can run nicely and doesn't escape. So all the research and all the code being done is really focused on ease the researcher jobs, or just simply verify the environment. Like PA-Fish, the paranoid fish tool, is checking hundreds of artifacts on a computer to detect if it can be detected as a VM or sandbox or whatever. But what about vaccination? So when we try to emulate an unhealthy environment for the malware, that's not researched that much. But as we saw, this actually works to defend against malware. And I'm not saying against every malware, so this is not like a silver bullet, but it does work against some. So there were actually some previous research on this, but this is the whole list I could find. So the first mention of this technique was back in 2008 in a white paper. Then Rapid7, 5 years later, had a blog post about placing some VM artifacts on a machine. And then recently in 2016, Gal Bitensky gave a similar talk about this. I actually found this presentation not after I made this, and it turned out that it's not by accident. He's working for a company I will mention later. And there are a few other tools against some specific malware to place some artifacts on the system to achieve this. But there is no real research on this topic, or not much beside that. So I wrote a couple of tools, and I'm not a developer. I recommend this book for everyone. Of course, it doesn't exist, but this is my development method. Probably the most efficient I could come up with. So I do some coding, but not that much. The first tool, I called it Fake VM. Initially, I wrote it just to see how to implement SSDT hooking in C for Windows. And as it uses SSDT hooking, so System Service Descriptor Table hooking, it works up to Windows 7 32-bit because you cannot do SSDT hooking afterwards. And it can emulate VirtualBox or VMware files or registry keys being present on a computer. And it's basically quite easy to extend with anything else. So I will run PAFish on this computer, which will try to check, okay, how this computer is seen as for being a virtual machine. Now this was actually recorded on a virtual machine, so it does see some stuff as a VM, like some drivers or MAC addresses or so on. But like for VirtualBox, which is this section, this is empty, so it frankly didn't detect VirtualBox because this is VMware. It detected some VMware stuff, serial number, MAC address, and so on. I didn't try to hide this, but nothing else. So the fake VM is a driver, so I need to load it. You can do it from command line, or you can just download a OSR loader tool or whatever, but it's not that difficult to do it through command line to load the driver. And once it's loaded, you need to start it, and it will try to fake some VMware and VirtualBox artifacts. So let's run PAFish again. So now you can see the VirtualBox section. It found quite a few stuff, like registry keys, files, and other parts, which is nice because this is a VMware machine. And if malware were trying to find this, it would find it and potentially exit. So like a simple driver like this could protect you against malware. And the same for VMware. So it found the same registry entries. I also wrote a controller for this driver to switch on and off VirtualBox and VMware, because whatever malware will check, okay, do I detect VirtualBox and VMware at the same time? If yes, then probably that's not true, because you cannot have VMware and VirtualBox machine at the same time. So I decided to be able to turn it on and off. So in this case, I turned off VirtualBox, but I kept VMware on. And if we run again, then you can see that the VirtualBox list is nice. So it wasn't detected, but VMware is still traced along registry and the files as well. You can also turn off entirely the driver. So the driver can work, but you can disable it. So basically unhook. And then we will go back to the original state. So VirtualBox is still off, and we have much less VMware stuff. So like registry files are not seen anymore. Okay. Another tool. This is even simpler. It will create fake debugger windows, like a fake OliDebug and a fake WinDebug window. This is a very simple app. So I went on Microsoft website, and like your first Windows application with a single window, you copy paste, change the title, and there is one change in the code. You actually need to make the window visible. Now, it's inconvenient for users to have like random windows for protection, so you can just hide it or actually not show the window. But it can be still enumerated, so the windows is there, but it's not seen, so it doesn't disturb anyone. And it also doesn't conflict with any other window. And I wrote another tool, the find window tool, which will actually look for OliDebug and WinDebug windows with the standard Windows API malware uses. And you can see if I start the real WinDebug, it will be found. Now let's run it again. So now the windows are off. And let's run our fake debugger Windows application. And then let's rerun the find window utility to check if we can find these windows, if we were malware. And yes, we could find both of those, which is pretty nice, as malware will sometimes try to look for OliDebug, and if it's found, it will exit. And as we can see, it will just consume like half meg of memory, which probably not that big deal. And you can still start WinDebug. So the thing I wasn't sure here is, if I have a window called WinDebug already, can I have another window as WinDebug as well? But yes, maybe it's known to everyone, but it wasn't straightforward for me. And then if I key the application, then the windows are no longer there. The last tool is, I called it mutex grabber. So the idea here is many malware will look for various mutexes, mutants on the system, because it doesn't want to infect it twice. So like in case of a ransomware, it will place a mutant that it's already there, because it doesn't want to encrypt the files over and over again. It wouldn't make sense. So if the mutant is there, it will simply exit. Now, what's the best resource to look for mutants used by malware? It's sandbox results, possibly. So you can take malware.com. And what I did here, I wrote a small tool to monitor malware.com for mutexes. grab them and create them on the system dynamically. And as it can create compatibility issues because mutants are legitimately used by applications, so that's good stuff for Windows, we can whitelist known mutants if we want. And we can also save the list and load them later on. And the first I wanted to show is WannaCry has a mutant as well, which is checked on the system for existence. And I run this tool when WannaCry spread in the world, so it was very popular, and everyone was submitting WannaCry samples to malware.com. And I run this tool, and I wondered how much time it takes to find the WannaCry mutant from malware.com with this tool. And it didn't take that much, actually, like about a minute. So these are the WannaCry mutants. So it takes like half minute. So essentially, if a malware became known and people will submit it to malware.com for analyzing it, then you will get a quick, let's call it signature update from there, and your system will be vaccinated against those malwares. Now, there is another video that actually WannaCry will not work or will not do anything if we load it with these mutants. So we loaded the WannaCry mutants, then we can start WannaCry and it will simply exit. So after like almost 2,000 events, it simply quit and it haven't done anything. Now there is a small cheating here with WannaCry specifically, because WannaCry spread through a removed kernel exploit on SMB. So when it infected the system, it ran as a system on session 0, while if you are a user, then you will be on session 1 or above. So placing a mutant on session 1 will not be visible to any malware on session 0. So you actually need to place the mutant on the right session, but typically malware will run as the user, and it will be rare for it to run as a system through some kernel exploit or so. But if you want, you can place the mutants in both sessions. And just quickly how this tool really works. So I wrote it in Python. That's the only language I can write anything on it right now. Probably the GUI coding was the hardest part with Python. So it will dynamically monitor malware.com, and this list is dynamic, so you can switch off mutants, and as you can see, they are deleted from the system. You can whitelist mutants, which means that you cannot turn them on anytime after whitelisting, and you can save these lists to a file and load them later, and so on. So this is just a proof of concept, so it's far from being like a production grade application, but it can be useful to just play around with this. But what are the challenges with this? So this is a good area to research, but can it break normal software? Are there any compatibility issues? I don't know, probably yes, especially with mutants. There might be other applications that care if they are being debugged. I just heard from one of my friends that like Spotify doesn't want to run if only debug is running. So you can break legit applications with this. What about low-level vaccination, like the red pill? And you need to do it in a clever way. So you cannot just say, I have 20 AVs running on this machine, because that's not true, that's not realistic. You cannot say that VirtualBox and VMware is running on this, or VirtualBox or VMware tools are running on this machine, because that's also not realistic. You can, but it's not typical. And I wonder if there are any production-grade solutions for this. And I found two. Where there is the Hitman Pro Alert, which nowadays is under Sophos. You can do some vaccination with this. It will place some entries in the registry, similar to what my driver did. But that's all. So it doesn't do too much. Actually, it has some handy features to protect the machine. And this is one of them, but it's not. It does something, but not not that much. And there is another tool, and so this is not advertisement here for these tools. I was just curious if anyone is dealing with this idea or technology. This company is actually dedicated to their product for this technology. So to mimic or to show an unhealthy environment for a malware. I don't have any experiences with them, so I don't know how good or bad it is, but really they are the only one who are seriously dealing with this topic. So as some closing thoughts, I think it's an interesting area because, as we can see, it is effective against some malware. Again, I want to highlight that this is not a silver bullet, so you will not stop every malware with this because some malware just don't care. But you will stop some, which is already pretty good, I think, considering how the typical AVs are performing these days. I think it should be more commonly researched, mostly by vendors. And I hope that it can have two long effects if this is being researched and deployed actively. One is that malware will need to adopt to this, and they will say, okay, they will stop caring about VM and debugger because it became so common between everyone. And this is good because then it will ease the researcher jobs. The other outcome could be that they don't care about this technology, which is good because we can protect against those malwares. Now, probably the outcome will be a third. They will evolve, as always, so us in the future. And yeah, who knows? But again, currently this area is not widely researched, but I hope I can encourage people to do it. So that was all from me. I don't know if you have time for any questions.